Okay, so let's work through this together. So the first question is asking for the coordinates of A. And so I find A, and remember coordinates are written as X, Y. So I want to say how many do I go over, and then how many do I go up or down. So I go over 3, so that's my X coordinate, and then I go up 2, which is my Y coordinate. So the coordinates of A are 3, 2. Now looking at B, I don't go left or right any. I stay on 0, so it's 0. And then I go down 2, so down means negative on my Y, so this is going to be -2. For the coordinate C, come to C, I'm going to go left 1, 2, so my X is -2. And then I go down 1, so down, of course, on Y is -1. Now for D, again, I'm at -2. Here's D. I'm at -2, but this time I go up 2. So I'm at -2, 2. All right, to test to see if an ordered pair is a solution, what I want to do is I want to take this point and I'm going to plug it in this equation and see if it's true or not. So remember, I have an X and then I have a Y. So my X is 2, my Y is 7. So in my equation for the Y, I'm going to plug in 7, and for the X, I'm going to plug in 2. So my equation now becomes 2 times 7 minus 3 times 2. And the question is, does that equal 8? Is that going to make it true? 2 times 7 is 14. 3 times 2 is 6. So this is kind of a question mark for me here. 14 minus 6 is 8. So 8 does equal 8. That checks. So yes, the point 27 is a solution. Okay. Number 6, to determine if two lines are parallel, I must find their slope. Remember, to find slope, I take the y's and subtract, divided by the difference of the x's. Okay, so I need to find the slope of each line. If they have the same slope, then they are parallel. If the slopes are not the same, then it is not parallel. So for line 1, the slope, remember these are the points that I'm referencing here. I do the y's, so if you want to do y2 here, 1 minus 3 divided by, now subtract the x's, 3 minus 0. If you started with this first point up top, that's fine. Just make sure you start with that first point on the bottom. I know it's y2 minus y1, but it really doesn't matter as long as you start, whatever you start with up top, you start with on the bottom. All right, so the slope, 1 minus 3 is -2 over 3. So there's the slope of the first line. Now we need the slope of the second line. So I'm going to say the slope is, this time I'm referencing these points. So -5 minus 4 divided by, and now I'm going to do -7 minus -1, because I subtract the y's and then I subtract the x's. Okay, so I get negative, so if you do same, change, change, I get -9 over same, change, change, -6. Of course, a negative divided by a negative would be a positive. And so I'm going to get, I can simplify this by dividing both of them by 3. And I get 3 over 2. So it's really close. These are really close slopes, but they are not exactly the same. They have to have the same sign as well as be exactly the same. So no, these lines are not parallel because the slopes are different. Okay, don't miss where it says to explain on the problem, okay? right, let's move on to number 7. Number 7 asks us to graph a line with the given intercepts. Now remember, intercepts are places where it crosses the crosses the axis, either the x or the y axis, depending on what it is you're looking at. So this one says the line has an x-intercept of -3. Okay, that means go to the x-axis and go to -3, right? Oh, that is actually wrong. I apologize. These are going by 2. So 2, 4, 6. So -3 is actually going to be right here between 2 and 4. I apologize for that. So now the y-intercept is going to be 5. So that means go up to 5. Again, these are going by 2. So 2, 4, and 5 here. Again, I want to connect these. Use my straight edge. And so there's what your line should look like, okay? So remember, this is not the point -3, 5, okay? This says that it's crossing the x-axis at -3 and then it's crossing the y-axis at 5. So those are 2 different points. You need 2 points to graph a line. All right, let's look at number 8. Find the slope and the y-intercept. So to find slope and y-intercept, what I want to do is I want to put this equation in slope-intercept form. Okay, so I want to solve it for y, because in slope-intercept form, m is my slope and b is my y-intercept. Okay, so when I solve this, I want to SAD map my way getting y by itself. Okay, so the first thing I want to do is add 6x to both sides. When you do that, you have 3y equals, these are gone. Okay, so I have 6x plus 9. And if you did it the other way, it's not wrong. I just want my x to come first because I want it in this form. Okay. Now what I need to do is divide by 3. So it's gone on this side. So I get y equals 6x plus 9 over 3. Now I need to simplify a little bit so that I can find the slope and the y-intercept. So what I'm going to do is split this up. I'm going to divide both of these by 3. To get 6x over 3, 9 over 3. Now 6 divided by 3 is 2, and 9 divided by 3 is 3. So for this particular problem, again, slope, y-intercept. So my slope is 2, and my y-intercept is 3. Moving on, the slope and y-intercept of the equation. This is nice because it's already in slope-intercept form for me. Remember, this is my slope, this is my y-intercept. So all I have to do is say, well, look, I can get this from the equation. It's already solved for y. The slope is -3. The y-intercept is 8. Okay, nice when it's already solved for y for you. Number 10, graph the equation y equals 1/3 x. So this is actually has a y-intercept of 0, right? I can add a plus 0 to that. So it's in slope-intercept form. So if you think about it, that means that the slope, which remember is rise over run, is 1/3. And the y-intercept is 0. So when I'm in this form, the easiest thing for me to do is to first plot this and then apply the slope. So y-intercept of 0 means I start at 0. Slope of 1/3, remember if I'm rise over run, that means I'm going to go up 1 and over 3. So up 1 and over 1, 2, 3. Okay, you only need 2 points for the line. That is perfect. And that line is graphed. Okay. Number 11. This one is in standard form. And if you recall standard form, the easiest way to graph when x and y are together on one side is to use that cover-up method that we talked about and find the intercepts. So when I look at this one, if I cover up the y part, I have 3x equals 18. When I divide that by 3, I end up with x equals 6. That means that's my x-intercept. Remember, intercept is where they cross the axis. So 1, 2, 3, 4, 5, 6. Now cover up the other part. So cover up the 3x, and I have negative 9y equals 18. Again, solve that for y, and I have y equals negative 2. Remember, the y-axis is the vertical axis, so I go down 1, 2, and I'm going to connect these points here. And there is my line. Okay, standard form, intercept, slope, intercept, intercept, and apply the slope. All right, so number 12 asks us to look at number 11 and number 10 that came before and see if either one of them represent direct variation, okay? So before I show you that, let's recall that direct variation means it's in the form y equals ax, okay? You can't have anything else over here, right? It can only be a number times x, which means that my y-intercept has to be 0. Well, you can look at this equation here and tell the y-intercept is not 0. In fact, it's negative 2. That one can't show direct variation, okay? If I solved this for y, and some of you may have done it this way whenever you graphed, I have negative 9y equals negative 3x plus 18. Divide by negative 9. You can see already there's going to be something there that's added to the x, and I can't have that. Okay, so that one does not show direct variation for that reason. Okay, but if you look back at number 10, look at the equation for number 10. Okay, remember direct variation looks like this, y equals a times x. Well, if I let a be 1/3, that looks exactly like a direct variation equation. And if you look, it has a y-intercept of 0. So, for my question, do either of them represent direct variation? And if so, what's the constant of variation? Well, yes. In fact, number 10 shows or represents direct variation. Okay, so again, what's your constant of variation? Well, that's just the a. That's the number there that sits in front of the x. So looking back at number 10, 1/3 is my constant of variation. Okay, so a, or constant of variation, equals 1/3. Okay, moving on, number 13, evaluate the function. Okay, evaluate just means tell me what it equals. If x equals 2, that means what I'm doing is everywhere I see an x, I'm putting a 2. So f of 2 equals negative 3 times 2 plus 4. It's that easy. Plug in and simplify. So this equals negative 3 times 2 is negative 6. Plus 4 is negative 2. Okay, on to number 14. Number 14 is a little bit different. It says that h of x is 12. So now, where I see h of x, I'm going to replace it with 12. So I have this equation. So not h of x, but 12 equals 3x minus 3. Find the value of x. So let's solve it for x. Remember, we're going to go submap. Okay. I want to add subtract first, so I'm going to add the 3 to both sides. And I get 15 equals 3x. Again, solving for x, I'm going to divide by 3. 15 divided by 3 is 5. and it's solved. Okay? Moving on to number 15. The table shows the amount of money in dollars spent by a household on plants and flowers for certain years. Describe the rate of change, and here I want you to stop just a second and remember rate of change and slope are synonymous. That means they mean the same thing. We're looking at slope. This is like my x and this is like my y, and I'm just trying to find the slope of the line, okay? Describe the rate of change in the number of dollars spent during the time period. Well, let's find slope, because slope is rate of change. Pick any 2 points you want. Doesn't matter which two you use. I'm going to just pick these first two. And I'm going to subtract the y's. 134 minus 127 divided by 2002 minus 2000. Okay, 134 minus 127 would give you, let's see, 37. And 2002 minus 2000 would give you 2. So this is 7. The rate of change is 7. Up top is dollars. So dollars per, this is dollars, this is years. And I'm just looking over here to see what's what, right? Per 2 years. So that's the rate of change, $7 every 2 years. On to number 16. I see a parenthesis here. So what I want to do is go ahead and distribute. So I get 21x minus 27 minus 19x equals negative 15. Gather up your like terms here. 21x and negative 19x would give me 2x and now I have a two-step linear equation that I can solve. So I'm going to add 27 to both sides. And I end up with 12 and then divide by 2. Okay, and now I've solved for x. Moving right along to number 17, and we're almost done. Solving for x yet again. Again with the parentheses, I'm going to multiply through. Put this over 1, put this over 1. So I have 6 over 4x minus 12 over 4 equals 6. 12 over 4 is 3. And I'm going to actually change 6 over 4. I'm going to divide both of those by 2. Simplify it a little bit. So I'm going to have 3 over 2x. This is actually 3. Minus 3 equals 6. Now it's an easy solve. I'm going to add 3 to both sides. Run out of room here a little bit. Let me come right over here. So I have 3 over 2x equals 9. Okay, and to get rid of that fraction, I want to multiply by the reciprocal, so I'm going to multiply by 2/3. And I get, these are gone, I get x equals 18 over 3, which is 6. Okay, one more solve here, number 18. Again, the parentheses, so what I'm going to do is I'm going to distribute that 2 through. 2 times 5y is 10y. And 2 times negative 2 is negative 4. I need to get my y's together, so what I'm going to do is I'm going to subtract 10y on both sides. I get negative 4 equals negative 4. So because that's a true statement and my variables are gone, this means there are infinitely many solutions. Number 19, again with the solve, remember when we have a proportion, we need to cross multiply. So what I'm going to do is I'm going to say 2x minus 3 times, and I'm going to put this 2 in front so it makes it an easy distribute for me, equals 3, here's that 3, times x minus 2. Okay, we're going to distribute. 2 times 2x is 4x minus 6, 3x minus 6. Let's get the variables together first. So we're going to move the smallest. I'm going to move the 3x. It's gone from the right. 4x minus 3x is 1x. Negative 6 on this side, so I'm going to add 6. And a lot of you got stumped at this point. And I think the reason is because it cancels, but it cancels, but it's 0. And 0 is a perfectly acceptable answer to have. So no trouble there. The answer is 0. And the last one here, translate into an equation or an inequality. So what I want to do is I want to do some interpreting. Okay, product I know means to multiply. Okay, so I'm multiplying a number p and 10. So p times 10, or I could write that as 10p, is less than, not take the number away, but is less than 15. And there you have it.